Okay, this is methods for the 25th of July. We're covering 7.3 and 7.4. 7.3 is the integration of trigonometric functions sine and cos. The trigonometric function of tan is not in the methods course, so we need to work out what the rule for that is. We're also going to cover the integration of 1 on x. The integral of sine is going to be negative cos, and the integral of cos is going to be positive sine. If there is a linear inside here, ax plus b, we need 1 on a at the front. If there's a linear ax plus b, there needs to be a 1a at the front. And the same thing happens for our 1 on x. If I have 1 on ax plus b, I need a 1 on a as a multiplication out the front. Then it's log by c of the modulus of ax plus b, of course, plus a constant c. That gives us a general rule for 1 on x, that if I have the derivative on top of g of x, its integral will equal the logarithm of g of x, plus a constant c. Okay, some examples out of 7.3 and 7.4. 2h out of 7.3, I have this integral with respect to theta. I might just write that as being the integral of 1 minus 2 the sine of 3 theta minus pi d theta. So it's about theta that you're taking the integral. The integral of 1 with respect to theta becomes theta. The sine becomes a negative cosine, and I've got a 3 inside here, so it's going to be positive 2 on 3 cos 3 theta minus pi plus some constant c. Another example out of set 7.3 is question 4f. X squared minus a sine minus a cos, and it's all about x. That's going to equal x cubed on 3, which is the integral of x squared. The minus sign becomes a positive cos, and I've got a 4 there, so 1/4 cos of 4x. I have 3 on 2. The integral of cos is positive sign, so it will still be negative. I'll have a half divided by 3 on 2, which is times by 2 on 3. The 2's cancel to leave 1/3 sine 2x on 3x on 2 plus some constant c. They're the two examples out of 7.3. In 7.4, it's the integral of 1 divided by x minus 1. I might put the negative 2 at the front. Now it's in the form where I can, the value of a is 1, I've got a 1 there, so it equals negative 2 log by c of the modulus of x minus 1 plus a constant c. Another example out of 7.4, 1i, I can put the 6 out the front, 1 over 3x plus 2 dx. I have a 3 there, so I need 6 divided by 3 log base e of the modulus of 3x plus 2 plus some constant c. And the last example is out of question 2. I have 1 on x times x squared plus 2x plus 1 with respect to x. I can multiply that out to get 1 on x times x squared is x, 1 on x times 2x is plus 2, 1 on x times 1 is 1 on x. Taking the antiderivative with respect to x, the x becomes x squared on 2, the 2 becomes 2x, the 1 on x becomes log base e of x plus some constant c. Have fun.